Let's look at this next work problem. So it's just like the ones we've been looking at to do with work problems in calculus. Look at this function, S. S displacement from rest position. So that's this axis here. So rest position is 0, which is here, this axis here, rest position. Time along here, so as time goes by, this thing is displaced from its rest position. And so we've got some sort of motion like this. Now if we look at it, there's two parts to this function. First part is a sine function. T is time. So we can see the sine here, the sine wave. But the amplitude of the sine wave, if you think about the general function for a sine wave, the number in front of the sine function represents the amplitude. That's an exponential decay. So you can see by looking at this that the amplitude of the sine function is dropping off exponentially. Okay? So you've got one function on top of another, or one function multiplied by the other. Time in this function, time in this function. So this question involves a function where the independent variable, in this case time, appears twice. We've got to determine the velocity of the end of the spring. So this spring is oscillating backwards and forwards, as I've been indicating, oscillating backwards and forwards. What's the velocity of the end of the spring after 1 second? This function is the rate of change, is the distance, or displacement rather, against time. So if I find the rate of change of displacement with time, what's another name for that? The velocity. The velocity of this is given by the rate of change of displacement with time. So in this question, because it's a displacement question, some sort of motion question, when we differentiate, that tells us something specific, in this case the velocity. So when in the question it says find the velocity, that's telling me I've got to differentiate it, because the velocity is the rate of change of distance with time, or displacement with time. So I've got to differentiate this function. The trouble is that's not a straightforward function to differentiate, because the independent variable appears twice, and we've got one function multiplied by another, and that involves using one of the methods of differentiation that we were talking about at the beginning of today, and that's the product rule. So differentiating a function where we have one function, or we effectively have one function involving t multiplied by another function involving t, requires the use of the product rule. The product rule says dy by dx, and note the symbol y, make sure it's a nice long tail on the y, equals u times dv by dx plus v times du by dx. That is the product rule. The question is, what is u and what is v? So we need to talk about that. it's also useful to think about this rule in words. Okay, so I'll write it in words as well. So in our example, we have S equals AE to the minus KT, or in this particular example it was 2e to the minus 0.9t times the sine of 2 pi f, and f was in this particular example 5, so 10 pi t. So there's our two functions. We call the first function u and the second function v. So those are our two functions multiplied together. We can't combine the two functions because they're completely separate. We can't simplify it in any way. How do I know it's two functions? Because the variable t appears twice. And these two functions you can see are multiplied together. So product rule, product means multiply algebraically, so the product rule comes in when you're multiplying one function by another. In words, we think about this as the first function, so that's 2e to the minus 0.9t, multiplied by the differential of the second function, the differential of v in other words, plus the second bit, or the second function, sine 10 pi t, multiplied by the differential of the first function, the differential of this. So you can think of it like that in words. So in words we multiply the first function by the differential of the second function, and we add the second function multiplied by the differential of the first function. And it's worth trying to remember it like that. So going back to the original question, we've got to determine the velocity, so that's telling us we've got to differentiate it after 1 second. So we're going to differentiate it and then put in the time equals 1 second and find the velocity, or the rate of change of displacement with time at that point, okay, given these values. So, as in the previous practical examples you've been looking at, the method's the same. It's just that when it comes to differentiating it, we've now got to use another rule, whoops, to get this differential, because it's one function times by another. So let's go back to the question here and try and finish it off. So we've got as far as this, and now we want to try and apply the product rule to it and find the value of this differential, the velocity in other words, when t equals 1 second. So let's try solving it. So setting the problem out, it's up to you how you set it out, but we're after u and the differential of u and v and the differential of v. So it's almost worth writing them down. U equals 2e to the minus 0.9t. So what is du by dt? Which is e to the minus 1.8, e to the minus 0.9t. Bringing the 0.9 down, or the minus 0.9 down, and timesing it by 2. So that's that one differentiated. And then so now v equals sine 10 pi t. So dv by dt equals, bring the 10 pi out. Good. Okay, so we've taken each bit in turn and differentiated them. And now we just plug them into the rule. The rule tells me that the differential of s with respect to t, the velocity in other words, equals the first bit, which is u, 2e to the minus 0.9t, times the differential of the second bit, which is 10 pi cos 10 pi t. No, it's the first bit, which is 2e to the minus 0.2, yep, times the difference of the second, plus the second function, which is sine 10 pi t, yes, times the difference of the first one, which is minus 1.8 e to the minus 0.9t, running out of room, okay? So just for clarity, that's u, that's dv by dt, that's v, and that's du by dt. So you can see them there. Okay, that is the differential, but we tidy up because it's an awkward function to use entering the value t. Then we've got to find out what this differential is when t equals a given value. So we tidy up. If we look at it, we can see 2 times 10, we can collect them together to make 20. So we tend to put the numbers first, so 20 pi, then we put the exponential functions, and we finish off with the trigonometric functions. The reason why we do that is because at this one, if you're looking at this, you could be confused into thinking that I'm after the sine of all of this. I'm not. I'm only after the sine of this bit, and then I'm multiplying it by that. So put this first. So, tidying up, ds by dt equals 20 pi e to the minus 0.9t times the cosine of 10 pi t. Now the minus sign, the minus 1.8 at the end of this function here, means that the whole rest of it's going to become negative. So this becomes minus 1.8 e to the minus 0.9t times the sine of 10 pi t. Now we could use this, okay, this has been tidied up, to put in the values. We could put in t here, and here, and here, and here. But again, we can tidy up again. If you look at these two terms, and this is one term, and this is another term, we can look at things that are common to both. And because when we differentiate an exponential function, it doesn't change the power, this is always going to be the same in both. So I can take that part outside a bracket. So ds by dt equals e to the minus 0.9t bracket 20 pi times the cos of 10 pi t minus 1.8 sine 10 pi t. And that again is a very common thing to do. So now going back to the original question, let's remind ourselves of the original question. Here it is. We've got to determine the velocity after 1 second. So at this point, we've got a function for the differential, the velocity. So we just got to substitute in t equals 1 second. So going back to here, we now say when t equals 1 second, ds by dt, or the velocity, equals e to the minus 0.9, because t is 1, brackets 20 pi cos 10 pi minus 1.8 sine 10 pi. At this point, we could just bang the numbers into a calculation, that would come the answer. However, if you have in your mind the two functions that are the sine and the cosine, because we've got a cosine and a sine here, the cosine looks like this, and you know that. The sine looks like this, okay? Where this point here is one complete revolution. Now, of course, that's a 1, and that's a minus 1, that's a 1, and that's a minus 1. I'm hoping you've got in your mind those, and you know them, okay? What is the cosine of 10 pi? No. What's the cosine of 2 pi? 1. So what's the cosine of 10 pi? because it's periodic, it carries on like this. Okay, 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, they're all 1. So that becomes 1. What is the sine of 10 pi? 0 alpha. So that's gone. All of that's gone. So in fact, we've got that V equals, going back to here, V equals e to the minus 0.9 brackets times 20 pi. Because the cosine of 10 pi is 1, and because the sine of 10 pi is 0, all the rest of that's disappeared. So in fact, all we've got to work out on the calculator is that. So what is V, the velocity? So velocity turns out to be about 25.55 centimetres per second to 4 significant figures. If at this point here I decided I was going to work out the voltage by just plugging this in, and I wasn't going to try and use the fact that I knew that the cos of 10 pi was 1 and so on, it'd be fine. You plug this into the calculator and you'll get the answer. What's the thing you've got to be careful of that you do? What might mean you get the wrong answer? If you don't make sure the calculator's in radians, you will get a wrong answer. Okay? And that's important to remember, because it's difficult to know what answer you're going to expect in these situations. So whatever answer is going to come out in the calculator, you're going to put down. But if you're in degrees, you'll get a wrong answer. Doing it this way, knowing what the cos of 10 pi and the sine of 10 pi ought to be, means you won't make that mistake. But so it's fine to use the calculator and go through the whole thing, but check you're in radians. Otherwise, you'll get the wrong answer.